The AZUL board game by the team Never Played AZUL Before. The design decisions that we've considered are the min-max tree search, Q-learning tabular, Q-learning function approximation, game theoretics, and Monte Carlo tree search.
Well, in a min-max tree search, there are both maximum layers and minimum layers. In the maximum layers, it is our turn to make a decision, so we want to choose the move that maximizes our reward. And in the minimum layers, our opponent wants to minimize our reward, so we choose the minimum reward for us. The disadvantage of this method is time-consuming, especially at the start of the game. So we need to optimize this method. We use alpha-beta pruning and also limit the search depth and range. Besides, we also need an evaluation function to score the current situation, and we can terminate our search in time.
Q-learning. Both the tabular and the function approximation was not pursued given the large state space of the game. We need to take into account both the factories, the centers, and both players' board as representing estates. And during our experimentation, we noticed that for one player, this has 3.5 times 10 to the power of 10 states, which is approximately 500 megabytes of memory, which in a sense was not practically feasible. So we took into another way of using function approximation. But again, this was not feasible, given that there are around 500 action states, 5 types of tiles, and 20 tiles that can be theoretically picked up, and 5 rows that can be placed on. And again, we still need to know how the player's board looking like, which is around 500 megabytes of memory, which is itself, again, infeasible. So this has led us onto game theoretics, in which our initial design decisions take into consideration the local observable field and pick tiles that maximizes the score if completed, but it failed to take into consideration the impact it has on future scores. Take, for example, the top right corner, in which there's red tiles both in the center line and the bottom row. The bottom row red tiles exist because it is a move that minimizes the penalty. Even though this move minimizes the penalty, now that it fails to consider the impact that now other tiles cannot be placed on the pattern row, and then instead has to all of them go to the floor line, which can be worse than all. And it is true. We achieve 40% worse performance than naive player. So we adapt this to consider the probability of completing the pattern row given the current factory and center conditions and the opponent's board. The benefits out of this is that we're able to achieve a much higher score based on the observable field, but the consequence of this is that because the factory sample size is too small, it has little effect on the player, and it causes the agent to reach to the center often. And the performance-wise, we achieve roughly the same performance as a naive player. So now we move on to Monte Carlo tree search, which is our final agent used in the final tournament. Our objective reward definition is defined as maximizing the difference between our player's score and the opponent's score. The benefits is that it's able to make great use of the 1 second time limitation, as it does as many simulations as much as possible within that second, and it's able to disturb the opponent's actions. The downside is that it has terrible performance in the first 2 rounds due to the sheer branching factors. So it uses a naive strategy in the first 2 rounds. And although it has a high win rate, it has a low score in the final round. But because we're trying to win, it does not matter that much to us.
This is a typical scenario that our player beats another player. Player 0 is the naive baseline, and our improved Monte Carlo tree search player is the player 1. As we can see from the history, at the end of the round 2, these 2 sides have similar situations because they both use similar strategies in the first 2 rounds. The difference is that our player prefers to put tiles on the central 3 columns. Monte Carlo tree search was used from round 3. An interesting thing is that at the end of each round, the opponent player is forced to put a lot of tiles on the floor line, which makes its scores become lower and lower. Our player won this match, but it didn't get high scores. It only gets 30, because the goal of learning is to broaden the gap between these 2 sides. The gap is 27.